Hello, Algebra 1 students. I promise this will be the final part of the first installment of your summer videos. I've numbered them 1A, 1B, 1C. This is 1C. 1A was about young Gauss and the sum of the first n natural numbers. 1B was primarily about arithmetic sequences, finding the nth term of an arithmetic sequence. In video 1B, I mentioned that there are also geometric sequences, and I didn't give you any examples, so I'd like to do that. Geometric sequences are covered in Chapter 9 of our textbook. I'm not going to do anything with them this summer, but just to show you what they're like. The first one is 2, 6, 18, 54, 162, and so on forever. Now, obviously, those differences are changing every time. Up by 4, up by 12, up by 36. So there's something else going on here. It's not an arithmetic sequence. You should see by now that what's happening is to get the next term, you multiply by 3. Right? Start at 2. This is a sub 1. We're still calling it a sub 1. To get to the next one is times 3, times 3, times 3, times 3. In the second one, the signs are alternating, so that should give you a clue of what kind of number you have to multiply by to go from one term to the next. Think about it. If the signs are alternating, doesn't the number you multiply by have to be negative? And in fact, it's negative 2. Negative 5 times negative 2 is 10. 10 times negative 2 is negative 20. Negative 20 times negative 2 is 40. And 40 times negative 2 is negative 80. The third one, the number you multiply is not negative, but it's not a whole number either. What do you multiply 8 by to get 12? 1.5. And 12 times 1.5 is 18. 18 times 1.5 is 27. And 27 times 1.5 is 40.5. We're going to call the number when we get to arithmetic sequences, we're going to call the number you multiply one term by to get the next a ratio. And that's, again, not arbitrary. Just like the word difference wasn't arbitrary because it involves subtraction or addition. Subtraction's really addition backwards. The ratio. The number you multiply 2 by to get the 6 is 6 over 2, or the 3. 18 over 6 gives you the 3, the fraction, 18 over 6. The ratio, 18 to 6, is what you're multiplying each term by to get the next. 15 over 18. It works with the negatives too. 10 over negative 5. That ratio is the negative 2 you're multiplying by each time. Negative 20 over 10. That's a ratio. We defined that early in 7th grade. Two integers as a fraction is called a ratio. That's why those kinds of numbers are called rational, because they can be represented as a ratio of integers, right? 40 over negative 20 is again the negative 2. 12 over 8 is 1.5. 18 over 12, the ratio is 1.5. So we're going to be, when we get to geometric sequences, we will be talking about ratios rather than differences. That's it for geometric sequences for a while. Another piece of unfinished business, I just want to make the point, a point about the natural numbers. Here they are, 1, 2, 3, 4, 5, and so on. And of course, video number 1A involved finding the sum of the first n natural numbers, the story about Gauss. And then video 1B was primarily about finding the nth term of an arithmetic sequence. The natural numbers are an arithmetic sequence. They are the most basic arithmetic sequence that you can imagine. A sub 1 is 1. For the natural numbers, we start with 1. That's why they're called natural or counting, right? And what's the difference? What do you add to each term to get the next one? Also 1. So let me ask you this question. The natural numbers are an arithmetic sequence. What is the 3,749th term of that arithmetic sequence, known as the natural numbers? Don't overthink it. It's pretty easy. let's go through it, even though hopefully you know what it is, but let's go through with the formula. Remember the formula we developed in video 1B. The nth term of an arithmetic sequence is a sub 1 plus n minus 1 times d. Okay, so let's do that here. A sub 1 is 1. The first term of the natural numbers is 1 plus, now we're trying to find, this is n here. So in the parentheses goes n minus 1, which is 3,748. And the difference, next comes the difference, which is 1. Now, it might help to look at this sum backwards, which of course addition is commutative. So the 3,749th term of the arithmetic sequence known as the natural numbers is 3,748 plus 1. With the natural numbers are an arithmetic sequence, and the reason it's so easy is that the nth term of the natural numbers is n. We saw that here. The nth term of the arithmetic sequence known as the natural numbers is the n. It's 3,749. At the top of the board, I reminded us of the formula for the sum of the first n natural numbers. This was video 1A about young Gauss. We found that the formula was n times n plus 1 divided by 2. In this video, we're going to develop the formula for the sum of the first n terms of any arithmetic sequence, not just the specific one known as the natural numbers. See, we started with a specific case of the natural numbers. Now we're going to expand to the general case. And this is a process that happens throughout the learning of math. You go from the specific to the general. Let's take an arithmetic sequence that we're already familiar with. I'm pretty sure from a previous time we considered this one. Now, if we put plus signs between these, now up here it's a sequence, here it's a series. And either way, there are 5 terms. We're trying to find the sum of the first 5 terms of this sequence. And when we state it that way with the plus signs, it's a series. Okay, let's approach it the same way that Gauss did. Let's write this sum backwards. 14 plus 11 plus 8 plus 5 plus 2. And add. Term for term. You can see that all of the terms add up to 16, which, by the way, is 14 plus 2. This sum is the first term plus the last term. Each of the sums is the first term plus the last term. Now, in the case of the natural numbers, the first term was 1. So that's why we could say it was n plus 1. See, it's not always going to be 1. So this is a little bit more challenging, more general, but the structure is very similar. Okay? Now, how many 16s are there? There are 5, because there are 5 terms in the series. So we have 16 plus 16 plus 16 plus 16 plus 16. So the sum is 5 16s, but then divided by 2, because again, we don't want 2 of them, we only want 1 of them. 80 divided by 2 is 40. We can easily confirm this. 2 plus 5 is 7, 15, 26, and 40. Okay? Very simple. Here is an arithmetic sequence where a sub 1 is -5 and the difference is -2. You add -2 to a term to get the next term. If we put plus signs in between them, it becomes a series, and we're looking for the sum of all of them. -5 plus -7 plus -9 plus -11 plus negative 13 plus negative 15. Once again, just like young Carl sitting in his classroom centuries ago, instead of just grinding this out, let's write a copy of it backwards. Negative 15 plus negative 13 plus negative 11 plus negative 9 plus negative 7 plus negative 5. This time there are 6 terms. So we're going to have 6 sums here. What is each sum? Negative 20, right? Negative 20, negative 20. And once again, let me make this point. A sub 1 is negative 5. And A sub n, which is the 6th one in this case, is negative 15. Negative 15 plus negative 5. The sum will always be the sum, each of these sums that we're going to write down here will always be the sum of the first term and the last term that we're interested in, the one we go up to. Negative 20 plus negative 20 plus negative 20 plus negative 20 plus negative 20. What are there? 6? 6 of them this time, right? Yes. So these 6 negative 20s, the sum of this arithmetic series here will be 6 times negative 20, but then divided by 2 because we don't want to know the sum of 2 of them. We only want to know the sum of 1 of them. We could cancel here. 3 times negative 20, negative 60. Negative 60. We could confirm that. Negative 12, negative 21, negative 32, negative 45, negative 60. So once again, it works. I have 2 formulas on the board. The top one we're familiar with, and one of the points of this video is that the top one is just a specific case of the bottom one. This is more general. This is the formula for the sum of the first n terms of any arithmetic series. The sum of the first n terms of any arithmetic series. Now, you should notice some similarities in the 2 formulas. Well, first of all, the n and up in the numerator and then over 2. A couple of different websites that I looked up just now give the formula this way: n over 2 times a sub 1 plus a sub n, and that's correct, but I wanted to rewrite it in a different way to make it more obvious that it's similar to this. It's really this is really a specific case of this. So if we think of this as being over 1 and multiply, then it would be n times the parentheses over 2 times 1. These 2 expressions are equivalent, and you should know that by now. So this is the formula, and maybe we should try one more, but this time try one that we wouldn't want to have to grind out. So how about if we try the arithmetic sequence? We establish an arithmetic sequence of 7, and how about 17, 27, 37, ... Now that's a fairly easy arithmetic sequence to come to terms with. A sub 1 is 7, and the difference is 10, right? Well, we already know how to find, let's say, this is A sub 1, A sub 2, A sub 3, A sub 4. We already know how to find A sub 50, let's say. A sub 50. Now, I haven't gotten to the sum yet. I'm just, what we need to do, eventually what we're going to do is we're going to find the sum of 7 plus 17 plus 27 plus 37 all the way up to the 50th term. But in order to find the sum, we're going to have to know what the 50th term is. You see, because the formula contains A sub n. And in this case, the n is 50. Okay? So this is a 2-part problem. let's first find a sub 50. A sub 50 is going to be a sub 1 plus, that formula is not on the board, that's from previous. But remember, it's n minus 1 times d. Okay? Now, the a sub 1 is 7. The n minus 1, n is 50. So n minus 1 is 49. And the d is 10. The fact that the d is 10 makes this calculation pretty easy. So the 50th term of this arithmetic sequence is 497. Right? Now we are in a position to add, believe it or not, add all of those terms up. 7 plus 17 plus 27 plus 37 plus 47 plus 57, all the way up to 497. We're not going to grind it out. I'm not sorry. I got places to be. We're going to use the formula. And the formula, again, is very similar to what Gauss did. All right? What we're going to do here is, now let me just come back here, change it from a sequence to a series by putting plus signs in here. Okay? The sum is going to be, let's use this version of it, which I think is a little bit easier to deal with at this point because we have that one back there. And I hope I remember to come back here and explain why this is a specific case of this one down here. So n is 50, right? This n is 50. And then in this parentheses, we have to put a sub 1 plus a sub n. 7 plus 497. 7 plus 497. Okay, now again, I'm not going to write it out, but why is it 7 plus 497? Because if you take this sum and reverse the order and then match up, you're going to be adding a 7 to a 497. You're going to be adding a 17 to what? 487. And they're all going to add up to, these here add 7 plus 497 is 504, right? So you're going to get it here, you're going to get it here, you're going to get it the whole way. Eventually to the point where you'll be adding 497 plus 7 again, when you reverse the order and add term for term. But of course, we only want one of them, so we divide by 2. This is the formula. N, which is 50, the sum of the first 50 of this particular series, times a sub 1 plus a sub n divided by 2. 50 times 504 over 2. 25, we can cancel here 25, right? 504 times 25, 50 divided by 2. Since, you know, I could just say, well, just work it out, but let's see what it is since we've come this far. And hopefully I didn't make any mistakes here. I could have done 50 times 504 and then divided by 2, but instead I canceled here. 50 divided by 2 is 25. 25 times 504. Did I do that correct? No, wait a minute. No, I think I carried one when I wasn't supposed to. 0 carried the 2, 2. Yeah, that's a 25. I didn't make a mistake there. Come in 1, 8, 0, 10. I think it's right now. Check it for me, please. Use a calculator if you want to. I think it's 12,600. Okay, let me try. I'll try it the other way. 50 times 504. 504 times 50 equals divided by 2 equals 12,600 is correct. one last point. I think it's the last point about this idea that the formula we developed from the Gauss story is a specific case of this one, you see. So this is the sum of the first n terms of an arithmetic series, okay? N times a plus 1 plus a sub n over 2. Now, if you compare it to this one up here, it's the same n. That's how many we're adding, how many terms we're adding together, and the same divided by 2. Now, up here, it's n plus 1, okay? Well, in here, it's a sub 1 plus a sub n. With the natural numbers, a sub 1 is 1. The natural numbers begin with 1. So this a sub 1 is that n, all right? And this a sub n is the nth natural number. Remember that funny example before? What was it? What I asked you, what was the 3,749th term of the arithmetic sequence known as the natural numbers? Well, it's this, the a sub n is the same as n when you're dealing with the natural numbers. Okay, let me make that point one more time. This a sub 1 in the general case for the natural numbers is 1. The first term of the natural numbers is 1. And the a sub n, the nth term, a sub n is the nth term of the arithmetic sequence. Well, the nth term of the arithmetic sequence known as the natural numbers is n. Okay. So that's the end of the first of 3 summer installments. You should be seeing, when you receive these 3 videos, 1A, 1B, 1C, you should be seeing, I guess I'll make 3 worksheets, probably, haven't made them yet, to go along with these videos, which I'm going to ask you to work out for yourself, because I would like to think that you're carefully watching these and maybe even re-watching them. And as far as I know, they'll be permanent. Hopefully, you could go back to them if you need to. When we get to these topics during the school year, you could come back to these videos for review purposes. They're always there for you to look at. Watch them carefully, pausing and thinking about it if necessary, re-watching until you come to that deep understanding of what's going on. And then being able to successfully work through the problems, the written problems that I provide for you along with the videos. That'll give you an idea if you've truly reached that level of understanding. You create your own math story. And hopefully it's the same one that, you know, everybody, hopefully it's the same one that's right, the one that's in the books, the one that the teachers know, and so on. But you're going to come to that understanding through your own path. I'm your guide. Don't be satisfied. Don't stop until you have that moment, as you young people like to say, I get it now. And it's a wonderful feeling. So give yourself that feeling. I'll see you again later in the summer with different topics as we get ready to study high school math, Algebra 1. Bye-bye for now.